Hello everyone, welcome to Canal Physics. This video will be a very brief introduction to physics. So as you may know, mathematics is a huge part of physics, and being able to use a formula or formulae is essential for success in physics. So what is a formula? It's simply a relationship between different quantities. And we know what a rectangle is, and that there are three quantities we can look at: width, length, and area. And these three quantities are related by this formula: area equals length multiplied by width. And in a formula, it is more convenient to use symbols. So for area, we use capital A, length we use lowercase l, and lowercase w for width. But we can simplify this even more, because in algebra, we don't need to write the multiply sign. We can just write the L and the W adjacent to each other. This implies multiplication. And you can write this also like A equals WL, because the order of multiplication doesn't change the answer. Following on from our rectangle example, we've looked at three quantities: length, width, and area. So quantities can be put into one of two categories: fundamental or derived. I'm going to show you just four examples of each on this page, and length and width would be fundamental quantities from the example we looked at, because those are directly measured in a laboratory. But because they're both a measure of how far 2 points are apart from each other, we combine that into one quantity, which is distance, and we use lowercase d for that. We can use a ruler to measure that. I mean, you can use other things like a measuring tape, but I'll just give you one example of an instrument. Time is a common physics quantity to encounter, and we use lowercase t for that typically. We can use a stopwatch to measure time. Mass is another fundamental quantity, lowercase m, used for that, to represent mass, and we can use a balance, or sometimes known as a scale. Could be digital or mechanical, and or analog, I should say. And another one we come across in physics is temperature. And we use capital T for this, so it doesn't get confused with time. And thermometers are great to measure temperature. Once again, analog or digital. So in this list I've shown you here, just by chance, the symbol used is the first letter of the word. And as you can see, it can be capital or lowercase. But don't get too attached to symbols, because there'll be problems you do in physics where you have to assign your own symbols to quantities, and it's not as hard as it sounds. I'll go through an example soon. But let's talk about derived quantities. So derived quantities, as the name suggests, these are derived from other quantities, and these other quantities are the fundamental ones. So the fundamental quantities can be mixed up together to give you new quantities or derived quantities. So with the rectangle, we saw length times width equals area. So area is derived from length and width. So let's put area as our first example of a derived quantity. And we know capital A is typically used for that. A more physics specific example could be speed. Okay, and this is a good chance to show you that the symbol doesn't have to be the first letter of the word. So we use V typically for speed, and that's fine. Force force is another common physics derived quantity. And that's a capital F usually. And another one that's very important in physics is energy, another important concept and quantity, and we use capital E usually for energy. So you may have come across this in previous years in science, but there can be different kinds of the same quantity. So for example, kinetic energy. So you don't have to know what this is, but because we come across it in future videos anyway. But it's essentially the energy of motion. So when an object is moving, it has kinetic energy. And then there's another kind of energy called potential energy. So we can still use a capital E to represent these quantities, but they are different. So we want to try and distinguish them without confusing ourselves too much. So subscripts are a great way to do this. So when we put something here, that's called a subscript in the bottom right. If we put something here, typically like a number, that is a superscript, or if it's 2, for example, that would be power of 2 or e squared. But to make up your own symbols for quantities, you want to put a subscript next to the symbol. So we can put a K for kinetic energy and P for potential. So these are very common quantities in physics. So these are pretty standard for kinetic and potential energy, these symbols. But there'll be examples you come across in physics where you have to assign your own symbols that aren't really from a set list like the ones you're seeing here. So for example, let's say you've got two people in a problem and you want to assign a symbol for their mass, for their masses. So let's say you have two people, Malcolm and Reese, and you want to assign a symbol for their masses. Something you could do would be, well, I've got lowercase m for that because it's a mass quantity. It would be wise also to put a subscript, so just the first letter of their names, and that's fine. So this is a way for us to distinguish two quantities of the same kind. So in summary, quantities can be fundamental or derived, and there are commonly used symbols for these. They can be the first letter of the word or not. They can be lowercase or capital, and they can have subscripts as well when you want to distinguish two or more quantities of the same kind. Thank you for watching this video. If you liked it, please like and share it, and subscribe to my channel for more.